Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 6 in the CSRF module, titled CSRF where token is duplicated in cookie. Before we continue with the exercise, I'm happy to announce that today's video is sponsored by Intigriti. Intigriti is Europe's #1 ethical hacking and bug bounty platform. Although it is European-based, you do not have to be from Europe to hack on their platform. When they first approached me to sponsor my videos, I thought that they were the perfect sponsor because the majority of you who do watch my videos watch them because you do bug bounty. I've even gotten a ton of messages telling me that my videos help people find bugs in real-world applications, which honestly makes me really happy. So if you're interested in earning some money on the side by hacking applications legally, sign up to Intigriti using the link in the description, and make sure to tweet at me or comment below when you do find bugs in their platform, because again, it makes me really happy to hear these stories. Alright, enough about our sponsor, let's go back to the exercise. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsbigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, and Burp is set to on, so let's turn that off. Go back, click on Academy, go down, select the learning path, go down, select cross-site request forgery, and then go down to lab number 6, titled CSRF where token is duplicated in cookie. Alright, let's get started. This lab's email change functionality is vulnerable to CSRF, so we've got the vulnerable parameter is the email change functionality. It attempts to use the insecure double submit CSRF prevention technique. So it has some kind of technique to defend against CSRF attacks. However, it's an insecure one, and that's what we're going to exploit to perform our CSRF attack. To solve the lab, use your exploit server to host an HTML page that uses a CSRF attack to change the viewer's email address. So the goal of this exercise is to exploit the CSRF vulnerability to change the email address of the victim user. You can log into your own account using the following credentials, and it's these credentials over here. So fun fact about today is that I usually, when creating these videos, I usually prepare the videos up front. So I solve the exercise, I create my script and so on, and then I record the video. However, for this lab, I haven't solved it before, so this is going to be the first time I solve it, which is why the creds over here, we've got the creds of the previous lab because this is the notes document from the previous lab, since based on the exercise title, it might be very similar to the previous lab. But for now, we only need one set of creds, and these are the ones that are on the notes document. So let's access the lab. And while that loads up, we'll open up Burp Suite Professional, just like we do with other labs. So if you don't have the professional edition of Burp, don't worry. For the first part, we'll use the professional version, and then we'll script the exploit on our own. So hit next and then start Burp. This looks good. Next, we need to log into our account. And the password was Peter. Hit login. Alright, and this is the vulnerable change email functionality. So we'll add an email address, and before we do that, we need to set Foxy Proxy to send requests to Burp and hit update email. Should have intercepted the request in the proxy, so click on proxy, and here we go. This is the request. We're going to send this to repeater, turn intercept to off, and work from repeater. Alright, so we said that a page is vulnerable to CSRF if it satisfies 3 conditions. The first one is a relevant action, which in this case is the email address, the change email address functionality. This is definitely relevant because if we have control on changing the email address of a user, then we could potentially compromise the user's account. And so it has detrimental effect to the client if it's possible, which makes it a relevant action. So this is satisfied. The second one is cookie-based session handling. So the application has to be using cookies for session handling, which it does over here. you could see that it uses a cookie called session in order to manage the session of the user. So this is satisfied as well. The last one is no unpredictable request parameters. The application here uses two parameters. One is the email address, which is definitely predictable because it's the email address that we want to change to. So in this case, we can predict it. It's going to be the email address of the attacker. However, you could see that there is another parameter, a CSRF token, which looks like it's a random number and so is unpredictable. So at first thought, this looks like it's definitely not vulnerable to CSRF attack. However, depending on how this CSRF defense mechanism is implemented, we might be able to bypass it and still exploit the vulnerability. So in previous labs, we discussed testing CSRF tokens. That's when you only had a CSRF token in the parameters. However, as we can see in this case, we have a CSRF parameter, but we also have a CSRF cookie. So this doesn't apply in the lab. Let's move on to the next one. In the previous lab, we encountered a scenario where we had both the CSRF token and the CSRF cookie, and they weren't equal. So we applied a few steps in order to see if we could exploit it, and that's what we're going to do in this lab as well. Now, notice over here, the parameter starts with BMG and so on, and then the CSRF cookie is exactly the same as the parameter. So this is slightly different from what we saw in the previous lab. This scenario leads me to believe that they're using something called the double submit cookie or the double submit defense. And what that does is the CSRF cookie and the CSRF parameter are both sent to the backend. And if they're equal, so their values are equal, then the request is accepted. If their values are not equal, the request is not accepted. So you usually see this being used in stateless applications. So the applications that don't store any session state or session cookies in the backend. For example, applications that make use of JOT tokens. So they usually use these double submit defense in order to defend against CSRF attacks. Now, in this case, this is clearly not stateless because this looks like it's a random session. It has to be stored at the backend. However, they are using the double submit defense. And what we need to do is try to exploit it in order to perform a CSRF attack. So usually with double submit cookies, the cookie value doesn't matter because it's not stored in the backend. All it does is when you submit the request, it takes this value and then it takes this value over here. It checks if they're equal. If they're equal, it accepts it. If they're not equal, it doesn't accept it. So this could be anything. So let's just say, for example, test and say test over here. It should accept both of them. So let's hit send and we get a 302. That's a good sign. Follow redirection and we get a 200 OK message, and you could see that the email was changed to test.test.ca. So it doesn't really matter what the value of the CSRF cookie is and what the value of the CSRF parameter is, as long as they're both equal. So this is good. Now, in order to exploit this vulnerability, and we don't need this anymore because it's from the previous lab. So in order to exploit this vulnerability, what we need to do is find a location in the application to inject the CSRF cookie in the user session. And let's remove this right now. So that's an HTTP header injection. And then we also need a CSRF attack to the victim with a known CSRF token. And in this case, it doesn't have to be a valid token. It could be anything just like we saw over here, as long as that token is equal to the CSRF cookie that we're going to inject in the user's browser. So we're going to go back to the lab and hit my home. And hit home. So in the previous exercise, we noticed that there's a CSRF cookie and there's a session cookie. However, when we searched for an item, so let's say, let's change this up. Again, let's say hat and hit search. A new cookie was created called last search term, and it has the term that we searched on. So if we go to Burp Suite Professional and then go to proxy, HTTP history, you could see over here, this is our search functionality. So the search term is hat over here that we want to search on, and notice over here it set a cookie called last search term, and it contained the search term value. So if we could potentially exploit this, so if this is not properly validated, the user input, and it allows for dynamic generation of HTTP headers, then we might be able to get out of this search field and get the application to set the CSRF cookie for us. So let's send this to repeater and work from there. So to do that, we're going to apply the same thing we did in the previous lab. So add a new line. So that's done using %0d and then %0a, and then say set cookie. And then add a space. So that's 20. And then say CSRF is equal to, and in this case we just set test, and hit send and see if it sets the cookie, and it did. So notice over here it says set cookie, CSRF is equal to test. So we've satisfied this first condition. Now all we need to do is perform our CSRF attack, which we've done in previous labs. So to do that, let's go back to the email change functionality. That's the functionality that is vulnerable to CSRF. Hit engagement tools and then generate CSRF POC. This is only available in the professional edition. Again, if you don't have the professional edition, don't worry. We'll be scripting the exploit in the second part of the video that doesn't require buying the professional edition. So the first thing to do is click on options and then include auto submit script and regenerate. This adds a script tag in order to automatically submit the form. We're going to remove that in a bit, but let's start off with the beginning of the script. So we've got the form element, it changes the email address, it applies a post method. You've got the email over here. This is the email we want to change it to. So let's say test3 at test.ca, and then you've got another hidden element. So that's the CSRF token. In this case, we do want it to be test. So it can be anything as long as this and the CSRF cookie are of equal value. And then you've got the submit button. Next, we're going to remove this over here. Instead of automatically submitting the form, we're going to add an image element. So let's say image and then src. So the source of the image, and that's going to be the URL where we perform the header injection. So let's go to this one over here. That's where we performed it. First, get the domain of the application. Let's copy that. Put it in here, add HTTPS, and then add the header injection, copy that, put it in here, and this looks good. So I'm going to resubmit this to make sure that the application didn't time out, and it didn't. All right, that's good. So we've got the source of the image, and then we're going to say on error, submit the form. So document.forms0.submit, and close off the image tag. So this looks good. So what it's going to do is it'll first try to load this image by visiting this URL over here, which performs the HTTP header injection, and this is not a valid image, so it's going to throw an error, and when it does, it's going to submit the form. So this form over here, which performs the CSRF attack, this way it's all done in one go. So let's test this in the browser, copy it, and see if it works. Hit enter, and we get an invalid CSRF token, which is weird. So we've got CSRF is equal to test. That looks good. And I think we copied this incorrectly. I believe we missed a character over here. And yeah, it's a question mark character. And that's why this didn't run correctly. The CSRF token didn't set to test, and so it was invalid. And we could probably see that in proxy. Let's do that over here. So you could see over here the CSRF token is the one that was originally there, but the parameter is test. They're not equal, and so you get an invalid CSRF token, which makes sense. So now let's do this the correct way. Test in browser, hit copy, and then hit paste and send. And here we go. It changed the email address to test3@test.ca. So our attack was successful. Let's go back to Burp Suite Professional and look at the attack. So over here, it correctly set the CSRF cookie to test. And you could see in the parameter, it's also test. And since they're equal, the attack was successful. Now notice we didn't get a congratulations, you solved the exercise. And the reason behind that is because we used the Burp Suite server instead of the Web Security Academy exploit server. So we're going to do that right now just so that we get that message. So all you need to do is copy this over here, put it in the body, and then store, and then deliver exploit to victim, and then you should see the message. And here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability using Burp Suite Professional. Now let's script it on our own. We no longer need the POC generator. All we're going to do is use the features that are available in the Community Edition. So although I'm still using the Professional Edition, everything that I do right now, it can be done in the Community Edition. So let's go back to Repeater because we're going to need to see how this looks. And we'll go back to the first one and let's start our script. So we've got HTML and then body. And then we'll add a heading and we'll just say hello world. This is what the user is going to see. Next, we'll add a form element. And we'll say the action is to go to a certain URL, and that's this URL over here. Let's add HTTPS. And then the path, my account, change email. That looks good. Next, we're going to add the method, and that's post. And the reason I say post is because it's a post method over here. And that looks good. Let's close it. Next, we need to add the input elements, so the parameters that the request takes in. The first one is the email address. So let's say it's hidden, and the name is equal to email, and we get that from this over here. The value would be the attacker's email address. Let's say test5@test.ca. Let's close the input element. Create another input element. We'll say type is equal to hidden. The name for this one is CSRF, and we get that from over here. And the value is equal to test, because that's what we want to change it to. Now, because I've done this before using the value test, what I'm going to do is I'm actually just going to change this up and say the value is, let's say, hacked, and then close it off. So that completes our form. The next thing to do is submit the form, which we said we'll do using the image tag. So in the previous exercise, we saw a little tiny icon for the image when it was loading. This could be an indicator to the user that something is going wrong, and I don't want the user to know that I'm hacking him or her. So I'm going to say display is none, and this makes the image invisible. And then SRC is equal to the header injection. So that's the second window over here. Let's hit send to make sure it didn't time out. It didn't. That's good. I just really don't want to load it up again. Okay, put HTTPS. That looks good. And then the search term over here. And again, that has to be the same thing as the CSRF parameter. So we're going to call this hacked as well. And then say on error. Document.forms 0.submit. So if this error is out, then submit the form, and it will, because this is not a valid image. It just the URL of the HTTP header injection. Okay, that looks good. Let's close this off. The last thing I want to do is submit the form in an iframe element because I don't want the user to know that I'm hacking him or her. And so we're going to add an iframe element. Say style to be equal to display none. Again, I want it to be invisible so that I'm stealthy. And then the name to be equal to CSRF iframe. That looks good. And then I'm going to instruct my form to submit through the iframe by adding the target element and then say iframe over here. So it was called CSRF iframe. All right, that looks good. Let's save it. The last thing we need to do is host this script on our server. So we're going to start up a simple Python server. I'm using Python 2. If it's Python 3, it's a different syntax. Hit enter, and now my script is hosted on localhost port 5555. So let's go here, close the exploit server, and send the malicious link to the user. So it's localhost port 5555 and the name of the script, so CSRF lab06.html. Hit enter, and here we go. All the user sees is hello world, and while the user is navigating this website, what's happening in the backend is that the user's email got changed. So let's see if that's the case. And here we go. It says test5 at test.ca. Now, if we go to Burp Suite Professional and look up proxy and see over here, notice that the CSRF cookie is equal to hacked and the CSRF parameter is also equal to hacked, and that's why it worked. All right, so we successfully completed the exercise by first exploiting the CSRF vulnerability using Burp Suite Professional and then scripting the exploit on our own. In the next video, we'll look at other faulty CSRF defenses. If you like the video, hit the subscribe and share button so that it reaches a wider audience. Also comment below what you learned and what you would like to see more of in the future. Thank you, and see you in the next video.